Hello everyone, here are the solutions only to yesterday's assignment. The other post, the PDF in Classroom, the other post that I have, you'll see this page, it's just a PDF, and then as you scroll through, I have step-by-step of all of these problems worked out. So please make sure you take your time to check and correct these. So pause the video just to see how you did initially, and then later on you can go back and open up the other PDF and take a look at the step-by-step work for the solutions. All right, so what we're going to do today will not be on the team assignment tomorrow. In fact, what we're going to do today, this assignment is not due till Thursday because I want you guys to just focus on preparing well to help each other out on the team assignment. For those of you working at home, obviously you're going to be able to use your notes, but you'll just be working on your own unless you have each other's email or numbers. You can call and work on this together. All right, so let's take a look at what we're moving on to. So here we're still solving equations, but we call these equations involving radicals. Sometimes we're going to have a variable under the radical. Sometimes it could just be a number under a radical. So this is how we're going to just tell the difference and refer to them. So again, pause the video to copy this down. But an equation is referred to as a radical equation when there is a variable in the radicand, which means under the radical. But an equation such as this, where we see a radical, but the variable's on the outside of it, there's only a number underneath, that's different. This is not a radical equation, it's just an equation that contains an irrational number that's that's posing as that radical 6 in this case. There is no variable in the radicand. So we're going to go through several examples here. First, we need to know which type of an equation we're working with in order to know how to solve it. All right, so if you take a look at number 1, again, pause the video to copy this down if necessary. Notice where the variable is. It is not underneath a radical, so we do not have a radical equation. We just have an equation that happens to have a radical 3 in it. Our goal is still to isolate the variable. So I first want to start by undoing that positive 2. So I'm going to subtract 2 from both sides. What I'm left with is still a negative x radical 3. 5 minus 2 will give me a 3. So this is still x, or negative x, times a radical 3. So what I want to do, I want to get rid of the negative and the radical 3. So I'm going to divide both sides by negative radical 3. So now x is simply equal, I can move that negative up top or just keep it out front, but a negative 3 over radical 3. And now what I want to do, I can't have that radical 3 in the denominator, I just want to rationalize the denominator by multiplying top and bottom by radical 3. So now we get x is equal to negative 3 radical 3. Our denominator is just going to turn into a 3. And we can go a little bit further. These outside 3's do divide out, so we're just left with a negative radical 3. Now as we work through number 1, pause the video. You guys give number 2 a try if you like. If not, just continue playing. This one is very similar. Notice the x is not underneath the radical with the 5, so that radical 5 is just a number. But I do want to start by moving the 4 to the other side, so I want to subtract 4. So we're going to get 2x radical 5 is equal to negative 4. Now just so you know, just because the radical 5 is after, it just looks a little bit nicer this way, but it does make things a little more confusing if we go to try to divide. What we could really look at here is 2 radical 5 times x equals negative 4 if it helps this way. And also to help us see that we need to get rid of the 2 radical 5 at once. So I want to divide both sides by 2 radical 5 because that's like the entire coefficient. So now x is going to equal, now I could simplify the negative 4 with the 2. This just becomes negative 2 over radical 5. And like number 1, I'm ready to rationalize the denominator. So I multiply top and bottom by radical 5. So now x is going to equal negative 2 radical 5 over 5. Let's take a look at a few more examples. All right, now number 3 is very similar to number 2, so I do want you guys to pause the video to try this one on your own. But then the problems start to change a little bit when we look at number 4. All right, so go ahead and pause the video a little more if you need more time. So again, the x is not underneath the radical. So all of this stuff is being multiplied. So I want to just get rid of the stuff with the x. So I'm just going to divide by a 7 radical 3. Again, this is like saying 7 radical 3 times x equals 3. So I could just divide both sides by 7 radical 3. So I'm just going to rewrite this. 3 and the 7 don't simplify like in the last problem. All I need to do now is just multiply by radical 3 to rationalize this. So now x is going to become 3 radical 3 over 7 times these two together will just give me a 3. So I get x equals, and now I could cross those 3's out, or I get radical, or 3 radical 3 over 21. Now that 3 and 21 will just become a radical 3 over 7. All right, now the problem's going to change a little bit for number 4. If you notice here, we have two y terms. So what I want to do, if they're not already, I want to get all the y terms to one side. So what I'm going to do is just move this y radical 2 to the other side. So I'm going to have 4 equals 4y minus y radical 2. Now, normally I would be able to combine like terms if this said 4y minus a 2y, but that radical 2 is irrational. So this is what we need to do. I can't combine them, but what I can do just to get it down to a single y is I'm going to factor out the y, and what's left is 4 minus radical 2. Now I need to get rid of this 4 minus radical 2, so I'm going to divide both sides by it. Now I'm going to flip this around. So now these are gone, so I'm going to have y equals 4 over 4 minus radical 2. Now I have a binomial in the denominator, so we've practiced this before, but we're going to multiply by the conjugate now because we cannot leave a radical in our denominator. So we multiply top and bottom by 4 plus radical 2. So I'll distribute the 4 to the two terms over here. So we're going to get a 16 plus 4 radical 2 all over 16, and then this will just give me a minus 2. So we get 16 plus 4 radical 2 over 14. Now the 16, 4, and 14, they all have a 2 in common, so I'm going to divide all of that by 2. So we're going to get 8 plus 2 radical 2 over 7. And there's our final answer. All right, so let's try 2 more examples like this. Copy down number 5. All right, so if you notice, we do have 2 m terms. They're both on the same side. So unlike the last problem, we don't have to move anything. But I can't combine them. Again, it would be different if it said m plus 5m. We would know what to do with that. We can't do anything with this. So our only move is to factor out an m. This would leave us with a 1 plus radical 5. So I want to divide both sides by the 1 plus radical 5. So I could say m is going to equal 7 over 1 plus radical 5. Well, now since, again, that's a binomial, I need to multiply top and bottom by the conjugate to rationalize the denominator. So we get 1 minus radical 5 over 1 minus radical 5. Carefully distributing here, we're going to get m equals 7 minus 7 radical 5 all over 1, and then we'll get a minus 5. So here we're going to get 7 minus 7 radical 5 all over negative 4, which is fine to leave like that, or a lot of times we don't really like to leave a negative in the denominator, so we simply take the opposite of everything, so we get a negative 7 plus 7 radical 5 over positive 4. Or sometimes you may even see the positive term go first, so 7 radical 5 minus 7 over 4. But again, this answer is good enough. Everything above it is the part I really care about. I want to make sure you're learning that. All right, example 6 is our last example. It's a combination. It's very similar to example 4. So I want you guys to pause the video, give this a try, and then resume playing. All right, so if you need more time, just pause again. Now, if you notice, we do have 2 n terms. I want to get them both to one side. So what I'm actually going to do is, let's switch this around. Let's do, just want to show you this way, n radical 2. I'll move the minus 3n over here, and then the 6 to the other side. It really doesn't matter which side you're going to move it to. But now we have 2 n terms over here. So I want to factor out an n. This is going to leave me with a radical 2 minus 3, and then that's going to equal negative 6. I need to divide by this radical 2 minus 3, so n is going to equal negative 6 over radical 2 minus 3. Keep that in parentheses. We're going to multiply by the conjugate, radical 2 plus 3. And what's nice about the way I have this ordered is the radical goes first, and sometimes that's nice. We may not get stuck with a negative, or sometimes we might. So let's see what we're going to end up with here. We're going to get a negative 6 radical 2 minus 18 all over radical 2 times radical 2 will give us a 2. Yes, we are going to end up with a negative value in our denominator, but that's okay. We're going to get a minus 9. So we get negative 6 radical 2 minus 18 over negative 7. Everything's negative, so let's just get rid of the negatives. Divide everything by negative 1, so we get 6 radical 2 plus 18 over a positive 7. All right, so the worksheet I have posted today, we're going to use this for the next several days. I just want you guys doing 1 through 10. Don't see this next page in the video. I'm only going this far, but there's a separate PDF of the worksheet. So again, this is due Thursday, just 1 through 10 only, because your team assignment is tomorrow, and I want to give everybody in class the entire class time to work on this. As always, guys, take care. Let me know if you have any questions.